Let's look at a couple of examples of trigonometric equations solving on the interval just between 0 and 2 pi. Say we have the tangent of theta over 2 equaling negative square root of 3. Okay, so notice that this is theta divided by 2, not just theta. So just for a moment, ignore that. Let's just find where the tangent of some angle is the negative square root of 3. Tangent on a unit circle would be the y-coordinate over the x-coordinate. So negative square root of 3 is technically over 1. So on the unit circle, square root of 3 is always over 2. Same thing with its counterpart, 1 over 2. So I'm looking for the place or places on the unit circle, again between 0 and 2 pi, where the y-coordinate, square root of 3 over 2, and then the x-coordinate is 1/2. Keep in mind that one of them has to be negative. Also keep in mind that the tangent function has a period of just pi. So what we can actually do is ignore the bottom half of the unit circle in this first step, and then we'll take care of the bottom in just a second here. So I'm looking for where the x-coordinate is 1/2 or negative 1/2, and then the y-coordinate is going to be positive. So if I'm looking only in the top part of the unit circle, I have to be looking in the second quadrant. Okay, so we're looking at the angle of 2 pi over 3. But this is not theta, this is theta over 2. Again, because we have a period of pi, if I were to add on any multiple of pi, we're going to get the same value for tangent. So I'm going to add on any multiple of pi, and I'm going to use k to represent that. And all k represents is an integer, positive or negative. So still solving for theta, I need to multiply everything by 2. So multiplying by 2, I end up now with the angle 4 pi over 3, so that when I divide 4 pi over 3, we're going to get back to where we were, and that gives us the tangent that we need. Okay, but there may also be some additional answers, so I need to involve that k is an integer. So the first answer here is when k is just simply 0. So when k is 0, that second part just disappears, so that theta is 4 pi over 3. Let's say that k is maybe 1, the next integer. So then theta would be 4 pi over 3 plus 2 pi, because k is 1. But keep in mind that the interval stops at 2 pi. So if I take 4 pi over 3 and add 2 pi, this is already more than 2 pi. So while this is still an answer, within the interval it is not. I'm going to cross that out. If I add another 2 pi, it's going to be even further outside the interval. So I don't want to keep adding positive k's. Let me go backwards. 2k equals negative 1. So theta would be 4 pi over 3 plus 2 pi times negative 1, so in other words, minus 2 pi. But then we have the exact same predicament. If I take away 2 pi, then I'm going to be less than 0. We need to be between 0 and 2 pi. So again, this is not an answer. So the only one we have is 4 pi over 3. Let's look at a second example that will yield some additional answers. Let's say we have the sine of 2 theta equaling negative 1/2. Okay, so this time we're looking for, because sine of 2 theta equals negative 1/2, we're looking for the y-coordinate. Okay, so looking on the unit circle, I'm looking for where the y-coordinate is negative 1/2. So two possibilities here. Where y is negative 1/2 is going to be at 7 pi over 6 and 11 pi over 6. So the sine of each of those is negative 1/2. Again, that's not theta, this is 2 theta. So 2 theta equals 7 pi over 6, or 2 theta equals 11 pi over 6. But again, there may be some additional answers because I haven't solved for theta yet. I've solved for 2 theta. So we're going to add on multiples of the period. Period of sine is 2 pi this time. So adding multiples of 2 pi, where again, k is an integer. Okay, so let's take a look at what happens when I divide by 2. So I have that theta dividing by 2, I would get 7 pi over 12 plus pi k. That's one possibility. Or the second possibility, dividing by 2, I get 11 pi over 12 plus pi k. Okay, so now I'm going to let k be an integer. So let's start with 0 on both of these. So that one answer is 7 pi over 12. And the second answer is 11 pi over 12. Both are between 0 and 2 pi. Let's let k be 1. So then I have 7 pi over 12 plus 1 pi, or 11 pi over 12 plus 1 pi. Let's get a common denominator. So 7 pi over 12 plus 12 pi over 12. So 19 pi over 12. 12 goes into 19 less than 2 times, so I know that this is going to be less than 2 pi, so that's an answer. Do the same thing on this one, 11 pi over 12 plus 12 pi over 12, so 23 pi over 12. Again, I'm checking to make sure it's in the interval, so 12 goes into 23 less than 2 times, so this is less than 2 pi, so that one's fine. And just looking ahead, if I were to do k equaling 2, then theta would be 7 pi over 12 plus 2 pi. If I'm adding 2 pi, then I'm already more than 2 pi. So that's not going to work for either one. If I try to go backwards and take away a pi, so letting k be negative 1, then I would have 7 pi over 12 minus pi, so that's going to be negative. 11 pi over 12 minus pi would also be negative. So these are the only answers that will work within the interval.